that 130 and point
130, see 130 is any point. 130 is any point on the line. It's not a specific point. And this is your direction vector.
So then, if that's the direction vector, what is 130?
Is any point on the line. 130 is any random point on the line. Point Q is 11 minus 1, 3. Correct? And point P is exactly perpendicular. They've given you. It's closest. So the closest distance is the perpendicular distance. So when you have your parametric form, your x is equal to 1 plus lambda, your y is equal to 3 plus lambda, and your z is equal to 2 lambda. So you assume that. So assume your x, it lies on the line. Na? So you assume your this and your x, y, z becomes the coordinates, where lambda is to be determined. So you're finding value of lambda so that it's perpendicular. And then we use the direction vector. My direction vector is 1, 1, 2. So I get my vector PQ is OQ minus OP. OQ minus OP. Minus 1 minus lambda. Minus 3 minus lambda. Minus 2 lambda. So that is 10 minus lambda. Minus 4 minus lambda. 3 minus 2 lambda. Now since it's perpendicular, your PQ dot direction vector will be 0. One, 1, 2 will be 0. So A1, A2 plus B1, B2 plus C1, C2 is equal to 0. So that will be how much? 12.
2.
Minus 6 lambda is equal to minus 12, correct? So lambda is equal to 2. Now as your lambda is 2, you put it back now. So you want the coordinates of P. So what is the coordinates of P be? 1 plus lambda, 1 plus 2, 3 plus lambda, 3 plus 2, and 2 lambda, 2 into 2. So P ka coordinate is 3, 5, 4. A vector is perpendicular to both L and line passing through PQ. Find a vector which is perpendicular to both.
So how do you calculate direction vector?
Direction vector?
Is it like x?
Which one are you talking? Which direction vector?
How do you calculate direction vector?
You can subtract the two vectors. So if you want a direction vector of PQ, so you take the vector PQ itself. You subtract.
Yeah.
So we know now P is 3, 5, 4. And Q we know is 11 minus 1, 3. So vector PQ would be, you do this minus this. That's your direction vector as well.
Yeah.
So that's 8 minus 6 and minus 1. That's your direction vector in PQ. What's your direction vector of the line? What is direction vector of line? 1, 1, 2. Correct?
Yeah.
So now you take, how do you get a third vector? You remember, you take the cross product. If you have one vector and you have another vector, to get a third vector perpendicular, you have to take the cross product. So you take the cross product of these two vectors. You can use your calculator to do that. They have saying then find a vector which is perpendicular to L and passing through PQ.
So I found a vector passing through PQ. I could just put the point P in the equation, lambda, and then you just use.
But that's not perpendicular. But that's not PQ. We want to find PQ.
Yeah, so PQ. So
vector PQ, no? How do you find vector PQ? So you can use your calculator to find the cross product of between these two vectors. 8 minus 6 minus 1.
So, but just for
cross.
I want to recall how to do it.
Okay. So if you're doing it by then you have to do minus 6 into 2, this into this, minus 1 into 1. So if I show it to you, you have to do this minus this.
Oh yeah, and then it's opposite. Yeah.
Correct.
Wait.
Now for this one,
Yeah, so
16
and minus 1.
minus 1, and this middle ka you have to do overall minus.
Yeah.
Acha, then next one would be
8 into 1.
8 into 1 and 2 this.
Minus.
So 8 into 1 minus 6. So that would be 6 2s are 12, minus 12 plus 1. Correct? Acha, this is 17, na? So minus 17 and 14. So minus 11, minus 17 and 14. So this completes this sum. So in any month during the study, it is noticed that the probability of a non-vegetarian becoming vegetarian is 0.1. So non-vegetarian, so if I put non-vegetarian, become a vegetarian is 0.1. Is vegetarian, let's say if you do this, suppose you do this, it is noticed that the probability of a non-vegetarian becoming vegetarian is 0.1, and the probability of a vegetarian remaining vegetarian is 0.8. Remaining, now this is wrong. So it is this way then. So the probability of a non-vegetarian becoming vegetarian, this way you have to go.
So they
Is
can
0.1. Yeah, they can flip the order. So non-vegetarian becoming vegetarian is 0.1, and this is your vegetarian remaining vegetarian is 0.8. So this is non-veg. Yeah. So you have to see. So you're reading it. So you're reading it this way basically. You're reading it this way, correct?
Yeah.
Interpret 0.9 in T. So what is 0.9 in T?
So non-veg remaining.
Yeah, 0.9 is the probability of non-veg remaining non-vegetarian. Yeah, so we find the eigenvalue. So what we do is determinant of t minus lambda I is equal to 0. You have to find a, so determinant of t minus lambda I, lambda 0 0 lambda 0.2. Now to find the determinant is equal to, so you can solve this on your calculator basically. So what are you getting a lambda? All lambda is equal to 1. Correct? 7 over 10.
Yeah.
I'm assuming your calculations are right. Huh? Now what do you do? So what is the eigenvalue? So basically what you do is, so your 0.8, 0.1, correct, into xy is equal to what? V?
Yes.
This is equal to what?
That is equal to you do 1. Oh no. Lambda, whatever lambda into x.
Lambda into xy.
Yeah.
So lambda into xy, correct?
Yeah.
You got that?
Yeah.
Okay, very good. 0.8. So what are you getting?
Yeah, I got that.
0.1x is equal to minus 0.1y. 1 minus 1 or 1 minus 1 1. Correct? Did you get that?
Yeah.
Yeah, minus 1 1 or 1 minus 1 1. What does the other vector be?
1 minus 7.
So the other eigenvector will be, we will do the second equation. 0.2x plus is equal to 0.7y. Same I am getting. You should get the same. Correct? Now you take 1. So this will be that. If you take 1, what will happen is 0.8x plus 0.1y is equal to x.
Yeah.
Achha, that one you take. You don't have to check this. This is just check if you want to.
So it's already said that one is
Yeah, you don't need to put that. So then this will be what? Minus 0.2x is equal to minus 0.1y. Huh?
0.2, huh? Yeah, that's.
So 1, 2. So this is given to you, minus 1, 1. So this they are calling it minus 1, 1. That is given to you. Find another non-parallel eigen.
Wait, no, it's 1.
It's 1, 2.
Yeah.
Find another non-parallel eigenvector, interpret it in context.
So 1, 2.
1, 2. So interpret in the context, what does it mean? It's a wedge, non-wedge. So in the context of interpreting, so that means if you have this transition matrix, correct, and you multiply that by the eigenvector, you will get the eigenvalue. What's the eigenvalue we got? 1, na?
Eigenvalue is 1 and
Isn't it? This was corresponding to 1, na?
the first one is. No, second one.
Second one is
The
corresponding
first
to
one corresponds to
0.7. That have given is correspond to 0.7. So what does it mean? Is this the steady state? Because if you do this into this plus this into this, that's 1. If you do this into this plus point, yeah. So is that the steady state? Because when you're multiplying this by the transition matrix, this is remaining the same. Right? So that means for every wedge there are 2 non-wedge. So when there are 2 non-vegetarians, for every wedge, the transition has no effect on the ratio. Correct?
Yes, sir.
It won't have effect on ratio, then it will remain as that.
Yeah.
So when Jeff plays basketball, the number of shots he takes during any 6 minutes of play can be modeled by Poisson distribution. So Poisson distribution is one mean, you know that, huh?
Yeah.
So X is the 6-minute play and the number of shots in 6-minute play. Number of shots in 6-minute play. Correct? So X follows a Poisson distribution with mean as how much? 2.5. Find the probability that Jeff takes less than 7 shots during any 12 minutes of play. So you scale up. So
Yeah.
12 minutes play, so y if you call it?
5.
So 5. So find a probability that y is less than 7.
0.76.
So use your calculator and get 0.76. So you just enter the value. But did you scale up the thing?
Yeah. So it's less than 7, so you put up the 6.
Yeah, less than 7 means you put upper 6. So lower 0, upper you'll put 6 because you want less than 7. And what do you take your mean as? Lambda, no? Just show me what.
5.
Yeah, you took 5, no? Yeah, that's important. Don't forget to scale up the mean.
Yeah.
It is assume that the outcomes of the shots are independent of each other and the probability of success of the shots is constant. The product